Let's give a proof of the following fact in group theory. Let G be a group, let little g be an element of the group, and prove that the order of G is the same as the order of its inverse with respect to the operation star. Remember that the order of an element is the smallest positive integer n, such that G to the n is the identity. If you want to give this a try, pause it here, go do it, and then come back here to see the solution. Okay, let's start the proof. Let G be an element of G such that the order of G is n. Then the very first thing I'm going to do is show you the following fact. If G to the m is E, if G to the m is the identity for some m, then I could multiply both sides by G to the minus m, and these two identities are equivalent, so this is an if and only if this is also true. And then on the left-hand side, this is the multiplicative inverse of G to the m, so the left-hand side is E. So if G to the m is E, then it is also true that E is G to the minus m, but G to the minus m is G minus 1 to the mth power. So we have that G to the m is E if and only if the inverse to the mth power is also E. And now I can use that equivalence to prove what I want, because first of all, I know that G to the n is E because n is the order of G, and therefore, by that equivalence, G to the minus 1 to the nth power is also E. That means that the order of G inverse is less or equal to n. It doesn't show that the order is exactly n at this point. I just know that G minus 1 to the nth power has to be E, and since the order is the smallest such integer, then we know that the order is less or equal to n at this point. And now I can do the following. I know that G inverse to its order is E, and now by the equivalence I just showed, that also tells me that G to the order of G inverse is E. But now I know that n is the order of G, and n is the smallest positive integer that G to some power gives me, so that power, G inverse, the order of G inverse, has to be at least n. And now I have that the order of G inverse is less or equal to n greater or equal to n, and therefore it has to be exactly n, and that's what we wanted to prove because that shows that G and G inverse have the same order.